Actually, there was a when I left at Danielle's that we won't talk too much about. Oh yeah. Yeah, talking about Danielle's parties. What happens at Danielle's party stays at Danielle's party.
Yo, what's going on, guys? Welcome back to the channel. If you're new here, my name is Tyson, and I'm a PhD candidate in chemistry at Yale and Berkeley. In this channel, we bring you quality academics, but we make sure to have a good time in the process. So if you're interested in being part of our little network of academic cool kids, definitely hit the subscribe button so you can keep rocking with us, all right? So what we're gonna do today is give you a little bit of an introduction to this wonderful world of chemistry. So maybe you're a student thinking of majoring in chemistry or pursuing a career in chemistry, or maybe you're just a chemistry enthusiast. It's none of my business. But either way, what I want to do is give you a little feel into these various fields of chemistry that people study. And so, I'm not going to do this by myself. Once again, I've gone ahead and brought some of the homies with me, some of my wonderful friends and colleagues from the Department of Chemistry over at Yale. So, colleagues, now at this point, you guys want to go ahead and give yourselves a little bit of an introduction?
Hi, I'm Danielle, and I am an organic chemist.
Hey, I'm Rishi. I'm an inorganic and materials chemist.
Sorry.
Hey everyone, I'm Ben, and I'm a theoretical chemist.
Hey y'all, I'm Jake, and I'm an experimental physical chemist.
Guys, I'm James, and I'm also somewhere in between organic chemistry and ChemBio.
All right, and so for today, I will be your chemical biology representative. So I like to think that I am formerly an organic chemist. I came into graduate school to study organic chemistry, but I joined a chemical biology lab, and so I'll be that representative. Now, guys, you guys want to go ahead and, let's get it started. Let's let the people know a little bit about what each of these fields feel like to be studied. Danielle, you want to start us off?
All right, so I said I am an organic chemist, so that is the world of carbon, which is our world. It's everything. It's everything we eat. It's everything around us. It's great. So we're kind of focused in on the upper right-hand corner of the periodic table, the nitrogen, the oxygen, sulfur, and we develop reactions, build complex molecules. We do that.
I am focused on everything else in the periodic table. Cube, periodic table on the screen, everything else. And that means we work with all the elements you've never heard of.
Actually, very quickly, Rishi. So, because I know this happens a lot, like people will be like, oh, dude, you study chemistry. Like it'll be a question maybe in trivia about some completely obscure element, which I actually know nothing at all about. I'm curious, are you more likely to know about these elements, or are you equally as unaware?
Yeah, it's actually, I'm equally as pathetic, I would say. So the one time that I was lucky enough to have a chemistry question on trivia night at the pub at the Griffin, I totally screwed it up.
Yeah.
Totally screwed it up. I got radon and radium maxed up. Yeah,
I had that happen to me once as well.
It was rough.
Right. Sweet. I'm glad to know that it's not only the organic / chemical biologists who are unaware of, some large portion of the periodic table.
There's a lot to know, man. There's a lot to know.
I haven't had the good fortune yet of having a trivia chemistry question, but theoretical chemistry, we're not actually dealing with any actual molecules. It's all just simulations, models. Either you're modeling it or you're making a model of it. And that saves a lot of energy, a lot of effort, a lot of money, and if you're doing it right, a lot of time in our predictions of the world around us.
Ben lives in a simulation.
Yeah.
So like I said, I'm a physical chemist, so I sort of work at the crossroads.
Do you have a name, physical chemist?
I do. I already introduced myself.
Oh, did we do that already?
Yeah, we did that first.
Oh, I'm tripping. All right, sorry. Okay, continue.
I was like, I can say my name is Jake again. So I'm an experimental physical chemist, like I said. So basically, physical chemistry sits at the crossroads between physics and chemistry, sort of obviously. We might not be as good at the math as the physicists are and can't make chemicals as well as the organic chemists. But basically what we're trying to do is understand why chemistry works. And we do that by doing all kinds of fancy, complex experiments. Complex is a really hard word to say.
Basically what Jake's trying to say is he gets to work with lasers.
Pretty much, yeah. Basically, we we try to understand chemical processes using different complex experiments, sometimes in collaboration with computational chemists or other synthetic chemists.
Well, and yeah, I'm James, and I started off more as a biophysical chemist, but now I'm doing more bioorganic stuff, developing drug candidates for particular targets, and also structural motifs prevalent in different natural products.
So James, you mentioned that you started off in biophysical chemistry, you now work in the same lab as Danielle, right? So you guys both do more organic chemistry type work. So I mentioned that, like, for example, I was interested in organic chemistry primarily, and then now I work kind of more in the chemical biology lab. Is it true for any of the other of you who, were you ever interested in another kind of chemistry to begin?
So I've gone the gambit. I started out doing organic synthetic chemistry, and then I realized that I was pretty garbage at that. And then I moved on to working on inorganic and materials chemistry, and that's sort of where I got interested in the materials that I work on now. But I realized that I wasn't that interested in making the best new material. I was interested in figuring out why my materials worked the way they did.
I've pretty much always been organic. I joined an organic lab in undergrad and kind of ran that up through grad school. But I do like the idea of getting to collaborate with different groups and kind of learn a little bit about different fields without that being like my main focus.
Nice. And so very quickly, sorry, I realized that I cheated you guys out of a ChemBio nation. And so chemical biology, kind of what you do is you use chemistry in order to develop tools or technologies that you then utilize. So, you might work with biomedical scientists and things of this nature in order to elucidate some type of health and disease or cell biology in general. So anyway, that's chemical biology for you guys. Jake, actually, very quickly, I've always kind of been curious in terms of physical chemistry, and I suppose this may apply to Ben as well. Like, what's the selection process between physics and physical chemistry?
The divide, I would say, is one of application, I think. The theoretical chemistry uses applications from physics that it then applies to try to understand the world around us. Contrast that with theoretical physics, where it's much more working from the ground up, and there are many fewer approximations. They're trying to build kind of universal models compared to theoretical chemistry, where we're happy to use whatever approximations we can, so long as by the end of the day, somebody can use it to tell me if this is going to be a viable chemical or for a drug discovery or development or solar energy, whatever applications you could think of.
So like Ben, I guess, because I know you're very good at comp sci, right? You're very good at coding. So like, why not just be a coder for Google and make 6K out of 6 figures out of college and stuff?
I always cared about the environment, and I wanted to make, and I still do, as my goal to like kind of help in the fight, in the race of making a compound that we can use to store solar energy. I feel like I'm much more of an individual who sees the beauty in chemistry in terms of its power, like how much you can get done with it.
Yeah.
You don't need to worry about politics if you can supply a source of fuel that's cheaper than the next thing coming out there, right?
Getting too political for me, man.
The thing is, you're scientist first, coder second.
Yeah.
Right.
Opinion is pretty much there is none, but you could think about it as how you approach a problem. So like a physical chemist has the chemical problem that you use a method from physics in, like spectroscopy. Whereas in chemical physics, a lot of the times you've developed this cool physical method, and you just so happen to get chemical insight out of it. So I think it's how you approach. It's just which side you approach the equation from.
Tyson, what about biochemistry versus ChemBio?
Yes, that's a good question. So it's funny because from my perspective, biochemistry and ChemBio are completely different disciplines. But even recently, I think Rishi, you saw, like I was doing some volunteer thing with this Lab Rascals group, and they put me down as a PhD candidate in biochemistry, which is, again, it's inherently incorrect, but it's okay. If you're watching this, I still love and appreciate the opportunity. Anyway, but so chemical biology, I would say, is more so chemical at heart, right? So where you are using chemistry, again, to solve problems in biology. And so many times you should be thinking on the level of atoms and bonds, and also it's kind of more of an application to cell biology in a lot of cases. Biochemistry, on the other hand, you're typically working with large macromolecules. So things like proteins, lipids, carbohydrates, maybe nucleic acids. And so chemical biology is more small molecules within large biological systems. Biochemistry I view as more large molecules, in many cases outside of those biological systems, because you're trying to study the properties of these large molecules themselves.
I think all these labels really, emphasize that, people often don't fit under one label, right?
Yeah, for sure.
So like sometimes I'm a wannabe physical chemist, sometimes I'm a wannabe materials chemist, sometimes I'm an inorganic chemist, sometimes I'm a physical inorganic chemist.
Right.
Especially nowadays, you find like a lot of the most interesting science comes at the crossings of these different disciplines. That's why people call it chemical biology, because it's right in the middle.
And even for us, like with organic chemistry, and Rishi said, they take care of the rest of the periodic table, but as organic chemists, we a lot of times utilize a lot of that as well. Like we'll have metal catalyzed reactions to kind of get to where we're going, and develop methods in that area too. So it definitely is kind of a little bit of a dipping into everything, no matter what your main focus is.
And I think that you guys are bringing up something important, because something I definitely learned during my PhD process is that kind of where these labels can limit your ability to do science, in a sense, because I know that when I started off, I walked in thinking that I was the organic chemist in this chemical biology space and thought about only the applications of the organic chemistry, when I realized that really in order to even construct the molecules that I needed to make, I needed to learn a significant amount of physics to understand how the microscopy and the lasers that Jake is our expert in work, and of course also the biological system that I was studying. And so I think that if you're watching this again and you're interested in exploring one of these potential fields and these potential avenues, to keep in mind that it's more so a label and a generalization, just kind of a general idea of what you will be studying, but ultimately you'll probably end up studying even more than just that one thing.
Yeah, I want to chime in on that. I would say, as cross as these divisions are, they do help us kind of, I think if nothing else, find that first step, find that lab in something that you like. Because while you'll be doing a lot of other chemistry, at the end of the day, the main meat and potatoes would probably still be close to that thing you liked about in class.
No, I think that's very fair. Actually, on that note, what's a class that you guys may have taken in your undergrad that has proven to be very helpful during your PhD? And so outside of Rishi inorganic chemistry or Danielle organic chemistry, Jake physical chemistry, maybe a chemistry class, but maybe something you took upper level, or maybe even something outside of chemistry that has contributed quite a bit to what you do now.
Well, if I'm being perfectly honest, the most useful chemistry class I've ever taken is general chemistry. And honestly, TAing general chemistry was the most useful thing. Sometimes I tell people I'm getting my PhD in general chemistry, which is kind of absurd. But, these fundamentals, they just keep popping up. And there's a reason why general chemistry is tough for a lot of students, because, I was still learning stuff as a PhD candidate. And I was teaching the class.
And you said I can't say organic, but I guess in undergrad, because I was doing all my research in more of a biophysical space, the reason I ultimately switched to organic / ChemBio when I came to Yale was because that class was, I guess, so profound to me at the time. Like during college, I was like, wow, this is the most interesting chemistry class. However, because I had started in the lab that I was in all throughout my college, my freshman year, and I had an ongoing project, I never got the chance to experience and what organic chemistry was in the lab. And so I was just always curious about it. And so when I got here, even though it was like a tough decision at first, that's why I decided to switch. And I'm glad that I did.
Mm-hmm. What I'm hearing basically from James is that, not to say that you got trapped in, right? But I think that for a lot of people, kind of the lab that you start doing research in undergrad ends up being what you spend a considerable amount of time studying. Is that the case for all of you as well? So is the area that you're in now, does that correspond directly with the first research opportunity, or maybe the first big research opportunity that you got in undergrad?
For me, that's definitely true. I took Orgo 1 and I was like, this kind of really fits. I like kind of the visuospatial. It's a little less mathy. It just kind of had like elements that really were intriguing to me. The fact that you could just like look on paper and kind of predict something that's going to happen, but then go and actually see if it does in the lab. So I joined an organic lab, and that's kind of definitely where I've stayed in that. So I think for me, like then all of my classes kind of veered toward that. Like when I took upper level classes, like we didn't have grad level classes at my school, but there were like upper level organic classes. So like an organic synthesis class, there was like an organic reactions and mechanisms class. And I think that really kind of honed in on, that's like what I like to do.
Right.
I also, I think that's probably a mistake I made in undergrad is I actually is funny story. In order to find the lab that I was going to join, I was really interested in joining a lab that had to do with energy. Similar to Ben, I wanted to get into the energy space. I wanted to make a difference there. And I found this lab. I found one paper where they mentioned something about solar light, something. And I was like, okay, I'll email this guy. That's not at all what they did. It was just like in the introduction, it was like, they're like super fundamental, inorganic, like they're making like these crazy compounds that'll never have any use ever, probably, but like are interesting. And that's what I ended up doing. And I just sort of stuck with it. It was interesting and I definitely learned a lot, but it wasn't what I wanted to do. And, but when I came to grad school, it took a while. It took a while to, it takes a while to break out of that mold of like, this is what I did. This is who I am. But I think once I finally came to terms with that, I was able to find the lab that was the right fit for me, which is where I am now.
So like I said before, I started in an organic lab and realized that I was pretty bad at that. So then when I transferred campuses going into my junior year, I got randomly placed into a materials chemistry lab that was working on solar energy conversion. And so that's when I sort of got interested in solar energy conversion, but I was still in the materials and organic side. But I was taking a lot of physics classes at the time. And I think I'm pretty sure I got an A in every single chemistry class that I took. But I had a really hard time getting an A in physics classes for some reason. So I think that's, sort of one of the catalysts that got me interested in the physics side of chemistry.
Right.
I didn't quite understand what was going on, but I knew that this is how you figure it out.
And so in addition to choosing a research lab, is there anything that you guys, any decisions that you made earlier in your chemistry career that now with the knowledge that you have, you'd have done differently?
Regrets. So what I would have done differently, I think, take some time to enjoy undergrad. I think there's a lot of focus on like getting career, but if you're in my boat, there was too much of that and not enough like stepping back and saying, yeah, these are 4 years. For me, they were not the best 4 years of my life. I don't know why everybody kept saying that, but worth saying that for people who are in the same boat, because I've heard that other way too often and I don't hear that one often enough. So, but anyway, I digress. Point is, I should have gone to more Duke games in my opinion.
Are you having more fun now, Ben?
I am. I'm back.
Grad school is the best 5 to 6 years of your life.
Like grad school wasn't nearly as like boring as in terms of the social aspects of grad school, weren't as bad as I thought that they were going to be. I mean, at least all of you guys are great people, fun to hang out with. Am I as fun to hang out with as I'm saying that you guys are?
Oh yeah, absolutely.
Yeah, we were so fun you left us.
Yeah, we had a party when you left actually.
Yeah.
We didn't tell you that.
Actually, there was a party when I left at Danielle's that we won't talk too much about.
Oh yeah.
But,
We know what that's about.
Yeah, talking about Danielle's parties.
What happens at Danielle's party stays at Danielle's party.
I will say that the social scene of grad school was my favorite surprise.
Right.
Yeah,
That's for sure.
for sure.
I can't tell if we just got lucky, or if I mean, you have to judge that when you visit grad schools, for sure.
Particularly, I know this is true of STEM programs. I can't really speak outside of that, but we're talking about chemistry anyway. Is that after you apply in chemistry, usually after you get accepted, you'll have a visiting weekend where you get to go for 2 or 3 days to each of the campuses actually to which you've been accepted and get a feel for what it's like there. So you should definitely take good use of those opportunities.
Another thing I'll just throw in: grad school is free.
Yeah.
Just
It's not just free. In chemistry, I'm pretty sure you always get paid. I don't know of any programs that don't pay.
So what are you guys thinking of pursuing So actually 2 questions. And so I can bring this back around now. So I'm interested in what non-academic careers typically look like in each of your particular fields of chemistry. But in addition to that, whether it be one of these non-academics that you're describing or an academic career or something else, what are you guys thinking of actually doing now that you're, in the next year for some of you, a couple of years for others, going to be wrapping up your PhD?
In terms of careers, I'm a little bit on the fence between going into academia and the non-academic career of not working in a national lab. So working in a national lab is one of these non-academic careers where you're a little bit closer to what academia is like. Like you're not trying to pull a profit for a company. You're still doing government-funded research, but a lot of it, you're doing it at a government facility, and that facility might have like an X-ray synchrotron or an X-ray free electron laser, and you're working with a $1 billion instrument to do research that literally no one else in the world can do, which I always thought that was really cool about that kind of thing. So actually, coming out to Cali in January to do exactly that.
Oh yeah. Are you going to be at LBL or somewhere else?
What was that?
Are you going to be at LBL per chance?
No, I'll be at Slack.
Oh, okay. That would have been super cool if you were right around the way.
But close enough.
Yeah. Well, definitely hit me up.
Each other.
Yeah, I can chime in. So inorganic chemistry, as I mentioned at the beginning of this, pretty much all of the periodic table. And similarly to lots of elements, I would say there are lots of careers that people go into. I've heard of people going into the semiconductor industry, into pharma, into biotech, into data science, into consulting. People do a lot of things. And but for myself, I am planning to do a postdoc. I am similar to Jake on the fence between an academic career and, in my case, an industrial career. So something in the energy space. A lot of battery tech companies popping up nowadays. And I'm sort of trying to decide whether the questions I'm most interested in answering lie in industry or if they still lie in academia.
I mean, like, I don't know what I want to do, but I was just like in the process, and I know I talked to you a lot about it, just like exploring all the different options. Because like in my old undergrad lab, like everybody went to consulting. So I thought like, I was like very aware early on, like going to consulting and just like leaving science was like a big option. And I know people here did that too, right? A lot of people did that here as well.
For sure.
Mm-hmm. And then I had like a really good friend who graduated from the Knowles group at Princeton, and he went to law. Like he's like a lawyer now. And so I was like, that's interesting too. And then somebody in our lab, like Daniel said, it's very common to just go to pharma and become a scientist. But also in pharma, there's like the whole business side. And then somebody who graduated from our lab previously went to consulting for a year and then went back to pharma, but on the business side. So he's on that side of things. Right. So, I talked to John about all these things. He's just like he just told me to consider the options, decide what I want to do eventually. But I guess I just don't know yet. But And then academia, sometimes when I meet like a cool professor, which I've met two so far, and then when research is going really well for like a number of weeks, I'm just like, maybe, just maybe, but probably.
Yeah.
And so again, guys, I just want to say thank you so much for coming out and sharing so much of your brilliant expertise with the viewers today. Guys, definitely make sure that you drop a like on this video to thank all of our lovely, wonderful guests for coming and sharing their knowledge and their expertise with us on this video. So, all right. Yeah, so that's it. I'll see you guys in the next one. Peace. Oh, yeah, you got it all. Yeah, I'll do something like that. So just do it. So just do your pieces or whatever again. So.
Oh, wait.
Yeah. Just do it yeah. All right, sweet.